So now we're looking at the limit as x approaches 3 of x plus 5 over x squared minus 9. And it might look like same old, same old. This doesn't look like anything new. The thing here is, if you substitute 3 into this expression, this limit has the form 3 plus 5, so 8, over 9 minus 9, 0. So it's not 0 over 0 this time, it's 8 over 0. And we need to look at what's going on there. Notice also, so factoring the denominator is not going to allow us to cancel a common factor. This would factor as x plus 3, x minus 3, but we have x plus 5 in the numerator, so there's not a common factor that's going to go away, which was in the past what we've done when the denominator is approaching 0. So I'm going to go back and look at this one in terms of a table, I think. So let's make a little table of values for this function. So where our f of x is x plus 5 over x squared minus 9. And we might get another dog bark in this video, but I hope not. Okay, so we would pick values close to 3 on either side of 3. So let's do 2.9, 2.99. I'm just going to do 2 values on either side. So we've got 3 here, which we're trying to think about what's the y values approaching as we get close to 3. And then, so I'll make this symmetric, so 3.01 and 3.1. Okay, now thinking about these output values. And I may not calculate all of these, or any of them precisely, actually. Let's just think about more generally what's going on. So when you plug in something very close to 3, the numerator is something very close to 8, right? The denominator, so if we pick something close to 3, let's say we pick something on this side, so close to 3, but a little bit smaller, then you're going to have 8 over, so 2.9 squared, take away 9, you're going to have something just slightly negative. So just to keep things simple, let me make it up. You're going to have something, let's see, very close to 0, right? Because we're plugging in something very close to 3, but slightly less than 3, so it's going to be slightly negative. So let's say it's negative 0.001. Okay. Well, so that would be 8 over, so let's see, this is tenths, hundredths, thousandths. That would be 8 over negative 1 1,000th. And so that would be, you can bring this fraction up out of the denominator, flip it over. That's going to be 8 times negative 1,000, so negative 8,000 here. And so this is just kind of ballpark sort of thing. If you pick something, so you're going to get very large negative numbers. That's what's going to happen when you plug in something close to 3 but slightly smaller. When you have a ratio that's a positive number, in this case 8, over a tiny, tiny negative fraction, so I just made up negative 1 1,000th, but some tiny negative fraction, then that ratio, so some non-zero number over a number really, really close to 0, that ratio is always going to be very large. It's going to increase without bound, or decrease without bound if it's negative. So looking at this side, if you had something slightly bigger than 3, when you square it, you're going to have something slightly bigger than 9. So when you take away 9, you're going to have something just slightly positive. So let's say it's 0.001. And you've got something very close to 8 on top. Well, so this is 8 over 1 1,000th. This is equal to 8,000. So it's going to be something like that. But my overall point is you're going to be approaching positive infinity on this side. If you look at the graph, so I would encourage you to type this into Desmos, there's a vertical asymptote at x equals 3. And so on either side of x equals 3, when you approach 3 from the left, it's going to dive down towards negative infinity. And when you approach from the right, the graph shoots up towards positive infinity. And so that's the sort of behavior you're going to see when you have a form non-zero number over 0. So I wanted this video to be a bit of a discussion about why that is. But the takeaway here is that anytime you have a limit of the form some non-zero number over 0, then that limit does not exist. And that's because this ratio, so you have some finite positive or negative number over a tiny, because the denominator isn't really 0, it's something really, really close to 0, then that ratio is either approaching infinity or negative infinity. And so the limit doesn't exist. And so, sorry, I was about to stop the video without a real formal answer. So the answer in this case is this limit does not exist because of that non-zero over 0 form of the limit. So if it's 0 over 0, you should do some algebra and you should simplify. And that limit may very well exist when you see 0 over 0. When you see non-zero number over 0, you can just stop. Limit doesn't exist.